Okay, good day, everyone, and thanks for joining us. I'd like to talk to you today about reasons you should build your data lake on Amazon S3. I'm John Mallory, a business development manager with AWS, who's been focused on storage and data lake, and spent quite a bit of time in this space talking to customers on this topic. So, what is a data lake, and why should you consider building one for your business? Essentially, a data lake is a way for you to monetize and get business value out of your data. An example is for all of you gamers out here, Epic Games and Fortnite. It's been a wildly successful game, scaled incredibly fast to 125 million players. And the way they do this is it's a engagement model with their customers and their consumers of Fortnite, where they essentially monitor interaction with the game in near real time, run analytics on that data that they're getting, and are constantly customizing the game and offering better player experience and different ways to engage with the game based on how the players are engaging. So essentially a real-time feedback loop that makes the game very responsive to customers' usage. How do they do that? They do that by building a data lake and collecting all this data coming from the people that are playing the games, analyzing it both in real time and then offline to get deeper insights, and are constantly customizing the game based on this data that they're getting and analyzing. So essentially, they use an AWS data lake both to host their game platform, but more importantly, to do the analytics that make that platform run and keep the players engaged. And so essentially what it looks like is they are using S3 as a data lake. They take all the telemetry data that's coming from these, large number of gamers that are playing the game at any one time. They analyze those amounts of data that are streaming in near real time using this near real time data pipeline architecture that's Spark and DynamoDB to present the data in real time and consume it in real time. But then they also put that data into S3 where they can transform it, run deeper analytics, run machine learning. And so it essentially gives them both a real-time interaction engagement engine as well as much deeper insights over time and over much larger numbers of customers to really optimize and add new features and keep the game responsive to what players want. So this has been a wildly successful architecture that's fueled their growth. There are 14 petabytes of data in S3 today, growing, multiple petabytes per month. And so, it's become a key part of their business. And this architecture that I'm showing is a very common architecture across many different use cases where you'll have a data lake that has a near-time path, but then a much deeper insights path. And those two worlds live together. So ultimately, when you start to think about data lake and what it means for your business, for almost all of you, it's going to be a journey. Whether you're just starting out, you've never done any meaningful analytics before, you're just used to maybe doing basic business insights, or whether you're a very innovative practitioner of analytics, there's probably always going to be room for improvement and room for evolution in what you're doing. So really, when we think about building architectures for data lake, we want them to be able to be built upon over time where you can transform and innovate at the pace that makes the most sense for you based on your business, based on your experience level, where you're going, but that you can do that in a non-disruptive fashion without having to go back once you hit a certain point in your evolution and having to start over again, move your data someplace else, rebuild your platform. That wouldn't work for most businesses. So really, when we think about data lake architecture that we're going to talk about today, one of the fundamental concepts is you have to be able to evolve around your data seamlessly as your skills grow, and even more importantly, be able to innovate and experiment with your data non-disruptively, determine if a new algorithm or a new processing tool is going to add value, and then quickly scale it into production. So that's going to require you essentially evolving your tools and methods around the data. Why do we use AWS and recommend AWS for big data and analytics and data lakes? Per what I was just talking about, a big part of this is agility. You want to innovate as fast as you can innovate and not have that blocked by the infrastructure or the tools or the platform that you're using to drive this innovation. So essentially, we're focused on giving you a platform that you can evolve in a very agile fashion, pop in new functions, new services, new capabilities as you need them, try them out and either fail fast and move on to the next thing for very low cost, or if that's a successful experiment, quickly scale it, because scale is the other element of a data lake. If you're someone like Epic Games or many of our other customers, you don't want to have something take off, be wildly successful, and then hit a point where you can't grow anymore because you've hit intrinsic limits. So essentially, the platforms and the tools we use to build data lakes are inherently scalable, up to hundreds of petabytes or exabytes of data. You've got to have a broad and a deep array of capabilities that you can bring to the data to get value out of the data, because your use cases are going to be unique to you. And as we talked about this being a journey, your skills are going to evolve. You're going to want to do new things, get new insights. And so you've got to have a very broad portfolio that isn't going to inhibit you, so that you can find, whether it's an AWS native service or a partner, the right tool for the right job. Another key thing is we got to be focused relentlessly on cost and optimizing cost, because essentially your data volumes, if you're successful, are going to grow beyond your imagination when you're starting out. And so obviously your budget's not going to grow that fast. So essentially we have to be able to keep cost optimized and not scale the cost of the infrastructure as your usage grows, but really allow you vehicles to keep the costs low over time. This probably isn't going to be an all AWS solution. You're either going to have legacy equipment on premise, or be integrating third-party data sources from many different places. And so we've got to make it easy for you to migrate your data and integrate your data with the data lake, but allow you to kind of keep a blended model for as long as it makes sense for you. And then finally, what this is really all about is, if the data is really driving business value, the faster you can get to those data insights and start to effectively utilize that data, that's a competitive advantage for you, quicker time to market, quicker ability to offer new services. So getting to insights faster is really one of the fundamental foundations we need to focus on when we architect this data lake. We have a lot of customers doing this. You certainly wouldn't be a pioneer if you decided to build a data lake on AWS. We've been doing this for several years now, but in the recent year or two, we've seen a dramatic acceleration of people deploying data lakes on AWS across all industries, all market segments. I mean, if you look at this list, which admittedly is an eye chart, you can see that there are a huge number of brand names, as well as probably innovative startups doing amazing things that you've never heard of. At the end of the day, the reason all of these customers have built data lakes on AWS is because they want to transform their businesses, take their businesses to the next level by more effective use of their data. And so we now have more than 10,000 customers who have done this, and it's growing very rapidly, hundreds of new customers every month. So how do we define the data lake at AWS? Since data lakes have been around for quite a while, there have been a lot of definitions that have been out there, starting from the early Hadoop days, where a data lake was really all about Hadoop. But we want to take a more expansive view. And the way we define it here is it's got to incorporate both relational and non-relational data. The traditional data lakes have been all about structured and semi-structured data from a variety of sources. But when we look at more and more new use cases, we start to see more unstructured data types, things like video or radar data or LiDAR data, I mean, just a whole host of many different types of data sources will now be processed. A couple of examples of that are we see a lot of people doing data lakes in the autonomous driving space, where you instrument cars, you collect all this data, you analyze it, and you refine your algorithms. That encompasses both a lot of traditional sensor data, but it also incorporates a lot of unstructured data in the form of video and radar and LiDAR data. And you really want to take those two data sources and combine those together to get complete insights. Another example is we see people using machine learning in the video space, where they can go and take a lot of historical video assets, apply machine learning, start to tag and annotate and classify that data automatically without human intervention. So really, you've got to be able to incorporate both of these data types into a data lake. As I'd mentioned, your data is going to scale rapidly. So you've got to be able to scale out to exabytes in the future. We don't have any customers that I know of that are building exabyte scale data lakes, but we do have quite a few customers who are doing tens or 100 plus petabytes in their data lake. So scale without limits is important. As I'd mentioned, you've got a wide variety of data types in the data lake. So you're going to have a diverse set of analytic and machine learning tools that you can bring to the data to process it. It's not just all about Hadoop or all about data warehousing, but it's really about a wide variety of tools that can dig in and do exactly what you want to do with the data. I mentioned time to results. One of the ways you can improve time to results is work on the data where it lives without having to take that data and move it to another platform before you're ready to get results from it. And so essentially processing the data in place is another way we define the AWS data lake. And finally, back to containing cost, it's got to be designed for both low cost of storage and cost optimized analytics, where you only pay for what you consume and you have multiple vehicles to start to cost optimize that. So breaking that down to the next level, what does a data lake on AWS actually look like? At the foundation, the central part of it, there in the middle of the screen, is S3. Really, S3 is the foundation for all data lakes on AWS. Just because you have data in S3 doesn't make it a data lake, but it does become the foundation that you put your data in and start to build a data lake on top of. So the first thing you have to do is get your data into S3. And we have a whole host of data ingestion tools to help you do that. Everything from our Kinesis family of streaming data tools to ingest data in, and that can be log data, it can be streaming video data, it can be many different video types. We've even got something called Kinesis Analytics, where you can actually analyze the data as it's streaming in and make decisions on that data before it even lands in the data lake. So I talked about, that kind of real-time data path. Kinesis Analytics is actually an important part of that. Like if you think of an IoT use case, like we have people that are using data lakes to monitor all the equipment in their factory, make real-time decisions about when a piece of equipment in, for example, a chip fab might be going bad and take action before it disrupts the entire flow. They might use something like Kinesis Analytics to analyze that streaming log data that's coming from all the machinery, determine when there's out-of-range data, and flag action before something actually fails. But you've also got a lot of traditional databases, either on-prem or in the cloud, that are relational data that you're going to want to integrate into the data lake. So we have a database migration service. A lot of traditional lab equipment. If you're in something like a pharmaceutical company, you may have lab equipment on-prem that doesn't necessarily speak object storage or an analytics interface, but is used to talking to a file device. You can use our storage gateway to integrate that, or our Snowball to collect that data and lift and shift it to the cloud. And then finally, you may have an existing Hadoop cluster on-prem, a data warehouse, large storage devices. You could set up Direct Connect and start to set a direct network connection between your on-prem environments and AWS services and make that look like one big hybrid system. So data ingestion is key to making your data actionable, and you've got to pick the right tool for the right type of data. The second part, which is really fundamental to building a data lake, and it's not a data lake without this element, is the ability to build a data catalog and to be able to search that catalog. Um, Without that, you don't really have a data lake. You just have a storage platform. If you're actually going to take your data, get insights from it, you've got to know what you have, what type of data it is, what the metadata associated with that data is, and ultimately how different data sets relate to each other. So that's really where AWS Glue comes in, is it is a very robust, very flexible data catalog that as data comes into the data lake, you can quickly crawl it, classify it, catalog it, and then take insights upon it. So without a catalog, it's just a storage platform, not a data lake. The next element, obviously, is you've got to be able to present that data once you've analyzed it, come up with insights from it to a whole variety of users. So you may do that directly. You may do that through analytic tools that speak SQL natively, or you may decide to put things like API gateways in front of it and set up a almost like a shopping cart data consumption model. So we've got a wide variety of tools like API Gateway, Cognito, AppSync to help you build those user interfaces on top of your data lake. Security and management of the data and managing security and governance is also a foundational aspect. It wouldn't be a usable data lake if it wasn't secure. Because ultimately, a data lake is really about taking a bunch of individual silos of data, integrating those, and getting greater insights because you're getting a more complete view. If you have a lot of silos, it may be easy to secure those individual silos, point a certain number of users to each silo, and you've still got to focus on security, but it's a much easier job than when you take all those data, all those users, and bring them to a common platform. So ultimately, we've got a whole array of security and management tools, which I'll go deeper into, to help you do that in a very secure, very robust, very granular fashion. But then ultimately, a data lake is really about getting value out of your data. And that comes down to what analytic tools are you going to use to do that. So we have a whole host of AWS native tools that allow you to both query your data in place using things like Athena or Redshift Spectrum or SageMaker or Rekognition, as well as a whole host of third-party tools that are much more performant and scalable for applications like Spark or data warehousing. And we also have a whole host of third-party ecosystem tools that you can snap into the data lake so that if you have a vendor that you're using today to get analytics insights from your data, you love them, odds are that you'll be able to move those to AWS and use those with your data lake as well. And before I go further, I'd really like to talk about two different models of how you process your data and get insights into your data, because we have both that are applicable to the data lake. The first is around user-defined functions where you may have custom functions that you've developed to analyze your data that just run on compute today. The usual path we recommend for that is to use our serverless computing capability, which is called Lambda. So you're bringing your own functions and code, but you can execute that against data in your data lake without having to worry about provisioning and managing and operating physical servers. So we use Lambda for user-defined functions, but then if you want more standardized functions like running SQL queries of your data or operating a data warehouse or cataloging and transforming your data, we have a wide number of what we call fully managed serverless services. And so essentially what these are is you just worry about interfacing and running the functionality that you want to do, and you don't worry about physical interfaces. And so essentially, if you take something like Glue, You can define glue jobs, which will crawl and catalog your data that's in S3, and then transformation jobs that will transform it. And you don't worry about physical infrastructure. It automatically handles all of the underlying functionality, all the physical infrastructure. You just write and run your functions. Same thing with querying your data. If you just want to do ad hoc SQL queries of your data, you don't have to spin up a third-party tool that might be something like a Presto running on Hadoop. You can just go to your Athena console, type your SQL queries, execute your SQL queries. We handle all the underlying physical infrastructure. So that's really the second element of these data lake is fully managed process and query tools. So as I'd said, I've talked a lot about Amazon S3 being the foundation of the data lake. There are a few very specific reasons we've chosen that. The first is if you're going to take all these data assets that have great value to your business, you're going to have to make sure that they're absolutely protected. They're never going to get lost or corrupted. And so S3 was designed for 11 nines of durability, high levels of availability. It's Amazon's second oldest service, about 13 years old. Has massive scale, exabytes of data, trillions of objects. And so it really is designed and proven at very large scale to be a rock solid platform. As I'd mentioned, security is fundamental. So there's a very wide number of security, compliance, and audit capabilities that are native to S3, or you're able to plug into S3 and integrate across to other tools that you'd use with the data lake. So that's another foundational aspect. Another is your data lake may grow if you're successful to have billions of objects. But the paradox is you want to be able to control those objects down to the individual object level to do things like give very fine-grained security and access characteristics, or set up very intelligent data management policies that are going to help you optimize cost. So essentially, there are a lot of controls and capabilities built into S3 that allow you to do control down to the individual object level, but do that at massive scale through automation. You're also going to want to get business insights into your data. And this is different than analytic insights into your data. This essentially is looking at how your data is being consumed. If you're building a data lake as a service for your end customers, where you're going to offer them analytic capabilities, for example, you're probably going to want to know how each individual customer is using that data and using the data lake so you can charge them appropriately. That's what business insights to your data provides, is that ability to see who's using what, how they're using it, how much of it they're using it. And then finally, as I talked about, you've got to get the data in before you can do anything with it. So there are the most ways to bring data into the data lake of pretty much any other platform out there. So these are all reasons why we've standardized on S3 as the foundation for the data lake. Another key reason is cost. If you think about data, data typically has different access patterns over its life cycle. When data first comes in, back to that gaming example at the beginning, that real-time data streaming in is what we call hot data. You're going to want to process it with very low latency and near real time. That's going to require high performance compute, high performance storage that is going to be more costly. It's just a fundamental law of IT that the faster you want to go, the more you're going to pay if you want to do that reliably. But then as that data ages and you start to collect more and more bulk data and maybe analyze it more infrequently, you can store that in a cooler and cooler tier that's much more cost optimized. And ultimately, you may want to just archive lots of data sets because you're going to not analyze them in real time. Or if you move into things like machine learning, you may train and build your models. And then periodically, you'll want to go back and maybe retrain those models as you get more sophisticated, as you realize, there are other data sets you want to add into them, or, you know, your business is changing. What you can do is you can archive massive amounts of data in Glacier or Deep Archive, and then just restore it whenever, maybe every 3 months, 6 months, a year, whenever you want to redo your models. So ultimately, you want to set up a tiering strategy that's going to encompass all of these and give you a way to optimize cost over a data's life cycle. And so an example would be you could use EMR with Hadoop on local EBS storage for the very highest performance levels, put bulk data into S3 for frequent processing, maybe migrate it to infrequent access, but keep it online for infrequent processing, and then archive massive data sets that you might use for machine learning and store those in Glacier and only restore them when you need them, so that you now have a very cost optimized environment. And we've really been focusing on making S3 better for these type of workloads by introducing more storage classes that are more optimized for these different scenarios. S3 standard is the workhorse for most data lake applications, but as the data gets colder, you may want to lifecycle it to infrequent access, maybe then subsequently set up a lifecycle to Glacier or Deep Archive so that you can really cost optimize over time. So S3 allows you to do that. It allows you to automate that and choose the right storage class that matches your requirements. But then we also found that for a lot of customers, they don't really know what their access patterns are going to be, particularly if you're building a multi-tenant data lake where you have a lot of different users doing a lot of different things at any given time. It may be hard to write a lifecycle policy to do that. So we recently introduced S3 intelligent tiering, where the storage is smart enough to monitor how your data is used, learn how the data is used, and tier the data automatically to save you money without you having to actively manage it. So that's another example of how we're continually optimizing S3 to build a better data lake. So you can manage it yourself, or we'll manage it for you, but it's all about saving cost. And as I mentioned, intelligent tiering has a frequent access tier, an infrequent access tier, monitors the patterns, and at the individual object level, optimizes it, but gives you all the same performance, durability, reliability, and availability as S3 standard does. And then I mentioned Deep Archive. This is a great place to store historical data that you either might have tried to write to tape and store off-site because you wanted to keep it, but you couldn't afford to, or you may have just thrown it away because you couldn't afford to keep it. But with Deep Archive, which is about $1 per terabyte per month, you can now afford to keep essentially all of your data. You don't have to manage tape if you are doing that. It has the same level of durability and reliability of all of our S3 storage services, and you can recover that data in hours. So if you're doing something like you've stored a lot of historical data, for example, if you're building self-driving cars, you've collected this, hundreds of terabytes per day of car, you've built your models, you've done a lot of processing of active data, but you don't want to keep all that historical data online because you're not going to use it anytime soon. But you do want to go back if a new camera comes out, a new type of sensor, a new algorithm you want to test. You could go back and recall a massive data set out of Deep Archive, train your models, and deploy new models, and then re-archive that data. So it really changes the game when you think about use cases like machine learning, where the more data you can use to train the model, the more effective you're going to be. Deep Archive becomes a very important component of your data lake. I talked about ingesting all data sources. Essentially, as I talked about, you need to have a variety of ingest methods to accommodate all different data types, everything from IoT sensor data to traditional databases, to on-premise equipment, to traditional Hadoops or data lakes that are on-prem, to offline data. But it's not going to be one or the other type of data that you're going to ingest. You're going to be ingesting all these different types of data into the data lake concurrently and at the same time. And it's all going to come in on different schedules. So the data lake needs to accommodate a very wide variety of concurrent data sources. And so we've got all the tools that allow you to do that. Including a new service, which, believe it or not, a lot of people, SFTP has been a way that enterprises have used to transfer data for decades. But we introduced a new transfer capability that essentially is an SFTP service, so that now if you're doing things like you're checking data in via SFTP, or you've got legacy mainframes, a lot of those typical on-premise legacy environments use this to move your data around. So you can now integrate this natively with your data lake so that you don't have to change your processes that you've already developed. So it's fully managed, it's secure and compliant, cost-effective and easy to use, and integrates all of that existing environment into an AWS data lake seamlessly. You may have a lot of data that you've collected in on-premise storage devices. You want to get that into the data lake, but it's difficult to keep those two worlds in sync. So we introduced AWS DataSync to help you do this. It's a very high-performance agent that you can install, point it at your existing on-prem storage, and it will automatically transfer and then synchronize that data with AWS. So it's easy to use. It's very high performance, and it allows you to kind of keep your on-premise environments that you may stage data in synchronized with your data lake in AWS without any manual intervention once you set it up. So those are well ways to get data in, but ultimately, once you get that data in and start to think about how to process it, a key concept for both reducing time and driving quicker time to results is going to be processing that data in place. So once you get the data in S3, you have these serverless services that can work directly against that data in S3. So as we talked about, that's Athena for ad hoc query, Redshift Spectrum for high performance data warehouse, SageMaker for training and deploying machine learning models, and AWS Glue to catalog and transform that data and get it ready for analytic use. Another way we've accelerated this and why we're continuing to try to make AWS better for data lakes is the ability to query the data intelligently in the storage layer. Because even if you're using a serverless tool like Athena or Redshift Spectrum, the traditional model that S3 and all other storage platforms used, including Hadoop for a data lake, was if you wanted to access an object, you accessed that whole object, an analytic tool scanned that object, pulled out the data in that object that it needed or that file, and threw the rest on the floor. That was just a fundamental fact of life. But we saw an opportunity to make that better, and so we introduced S3 Select, where rather than do a get on a whole object and retrieve that object before you could do something with it, you could push a SQL statement down to the storage layer, and the storage layer would only return the part of that object or parts of that object that match that SQL expression. So now you've got the storage layer itself doing a lot of the heavy lifting of scanning and filtering data before it ever gets returned to the analytics tool. And so essentially what this means is if you're pulling and accessing less data out of the storage layer, it means higher performance because the storage layer is doing that scanning for you, doesn't have to go over the network to another tool, and also much lower cost because a lot of analytic tools charge by the amount of data processed and scanned. So if you do that in the storage layer and only return that qualified data, that's up to 80% lower cost. So just an example of how storage innovation can make a much more optimal data lake. And we've continued to evolve this to add more different data formats, more types of compression, and we've even open sourced it so that a wide array of third-party tools like Spark or Hive or Presto on EMR, or for that matter, third-party Hadoop vendors or Spark vendors like Databricks have introduced support for it. So we're really trying to make this something that the broader ecosystem of tools can adopt and that you can benefit from. Um, and another new concept, I talked about this autonomous vehicle use case where you've got both traditional, what I call analytics data, as well as a lot of data sets like video and images and radar data that you would use HPC models for, where you'd spin up big compute fleets, build a specialized high performance storage layer, and then do your high performance compute um, in areas like autonomous vehicles or healthcare life sciences, when you're looking at things like genomics data or scientific research, where you may be looking at things like fluid dynamics data or complex weather data, you really want to combine HPC methods with traditional data lake methods and integrate all those types of data on a single platform. So to accommodate that, we introduced FSx Lustre. For any of you that have been in the high performance compute space, you know that Lustre has been the gold standard for HPC large compute architectures. But rather than have to build two separate environments to do this new type of processing, we wanted to allow you to put all your data in S3, but then be able to spin up a very high performance file system in front of S3 that could drive HPC compute clusters. And so that's what FSx Lustre is. You can load the data in S3 into FSx Lustre, process it with a large scale compute cluster. And we have customers routinely doing this with tens or hundreds of thousands of cores, write the results back out to S3 into the data lake, and then tear that file system down. So it gives you a way to do very high performance compute at a very low cost at a very large scale, only paying for when you're doing those high performance compute jobs. And so it gives you hundreds of gigabytes per second of throughput, millions of IOPS, sub-millisecond latency, so that the storage isn't going to be the bottleneck for these high performance compute jobs that you're going to want to run. But yet you don't have to build a separate infrastructure from your data lake to achieve this. Data formats are important for a data lake. There's no such thing as the best data format. All involve some form of trade-off depending on the workloads and tools. But really, there are a couple of optimized formats you're probably going to want to consider. While a lot of data comes in unstructured formats or loosely structured formats like CSV or TSV or JSON or XML, those are easy to understand and easy to process, but it's not efficient. So really what we want to get to for most analytics is what we call columnar compressed formats, like Parquet or ORC. And most of the industry standardized around Parquet, both because it has inherent compression. So essentially, if you take a given JSON file and convert it to Parquet, you're probably going to get about a 4-to-1 compression ratio, which means much less cost to store that data over time. But ultimately, because these are self-describing formats, they're much more efficient to process. And so you scan much less data. So ultimately, we really recommend that you take these raw data sources, process them, convert them into an optimized format, and then load that optimized format into your data lake. Maybe keep that raw data, compress it up, and then write it to something like Glacier or Deep Archive so that you have that historical raw data, but get it optimized before you put it into the data lake so that you get better cost, better performance, and get into a common format that more tools can use and share. So that requires a lot of data preparation. Historically, there'd been a lot of studies that found that about 80% of the work that needed to happen to get analytic value out of data was actually just getting the data ready to analyze, aggregating data sets, cleaning them, normalizing them, doing this transformation into optimized formats, refining algorithms. Those were all things that were a huge amount of the work that went into data lakes. And just last week, there was an article in the Wall Street Journal about a new report from Forrester that this isn't just a traditional analytics problem. This is a big problem for machine learning. And one of the top three reasons that machine learning um, programs aren't successful is because it's been too hard to get the data ready to process and to get good quality data to actually build models with. So it's been a legacy problem, but even today, with new tools like machine learning, this continues to be a problem. So, in the spirit of wanting to help you build a more optimized data lake, we decided to try to tackle this problem head on and really cut down the time it takes from having raw data to having data that you can actually drive analytics and machine learning with. And that's where Glue comes in. Essentially, it allows you to set up a catalog, prep, and ultimately transform your data in an automated serverless fashion. So you define your jobs, you define your schedule of how you're going to crawl and discover data and put it in a catalog and apply metadata to that. And then once you define all that, it's automated. You don't have to worry about managing physical infrastructure. You don't have to worry about manually running jobs. You're essentially setting up a automated data pipeline and only paying for the resources that you use to do that. If you've been using something like Apache Spark and Python to do this, which is very common, you can take that open source code, quickly port it to Glue because Glue is built on open source code under the covers, and automate jobs that you've been running manually today. And I mentioned that data is going to come in concurrently and on very different schedules. So ultimately, you're probably going to want to build an event-driven pipeline to do this data transformation and get it ready for use. And so essentially, Lambda, that serverless compute capability that I talked about, is going to be the engine to do that. So when your data arrives, you're probably not going to want to kick off a Glue job. You're probably not going to want to kick off a Glue job for every bit of data that comes in, but you may want to batch it and do it like every 10,000 objects that come in. So what you can do is set up Lambda functions that will count and decide when to intelligently start crawl jobs. Glue will discover that data. You can then trigger an optimized job to start to transform it into a more optimized format like Parquet, catalog those new data sets, load them into the data lake. If you're doing something like a data warehouse, maybe load those into the data warehouse and do that all in a very automated, event-driven fashion where you can write intelligent event triggers to do this in a way that matches your business flow processes. The next element I want to talk about, which I mentioned was foundational to data lake, is security. There are a lot of challenges to building a secure data lake. This is one of the hardest aspects of doing it successfully. You've not just got to control access to the data, prevent the data from being lost or accidentally deleted or overwritten, and be able to kind of track and audit who's touched that data, but you've also got to audit and report on all these capabilities. So these break down into data challenges and management challenges. And we have a wide number of tools to both control access to data and to metadata, meet compliance requirements, as well as manage and audit and track this whole process. So essentially, we have a wide array of security tools, including things like Macy, which can actually go and scan your data and discover PII or sensitive data. Identity is the foundation for building secure access to the data lake. Encryption is key to making sure that if someone inadvertently sees data they shouldn't see, that they won't be able to read it because they don't have the right encryption keys to unlock that data. And then obviously a whole host of compliance tools like CloudTrail that will allow you to audit the data. So really security is not one single thing. It's this whole portfolio of tools that's going to help you do this end to end. And when you think about data lake security specifically, there are two challenges. You've got to control access to the data itself, but you've also got to control access to the metadata. Because if you think about having a large number of users who may be doing a lot of different things with different data sets, one of the principles of security is least access. You only want people to be able to see and access data that they're entitled and that they need to do their job and nothing more. So that really comes into managing metadata and materializing unique views of the data in the data lake to match their capabilities that they should have. And so essentially, we use S3 permissions to control access to the data. And IAM is the foundation for that. So you set up IAM users, roles, and groups and start to map capabilities of who can do what, who can access what, who can take what actions with the data. That's all done via IAM. And then you use S3 bucket policies to control access to data in S3 and make it easy to share data sets in S3 across multiple accounts, multiple user groups. And all of that is driven and controlled and integrated from top to bottom by IAM, including which tools you can use to access and process that data. So IAM is really the foundation to data lake security. Too much information to go in for this webinar, but we have other webinars that focus on this topic or a number of recorded assets if you want to dive deeper into this, because this is the foundation for the data lake. And we just introduced a new capability because a big fear for people that build on public cloud is what happens if I inadvertently expose my data? Because ultimately, S3 is designed to be a public storage platform if you give the permissions to make data public, because you'll want to share your data with users, presumably, be it internal users or external users. But you've got to be able to make sure that that doesn't happen accidentally, that it's very deliberate. So we introduced block public access so that you now have via an API, a single point of management, the ability to make sure that even if someone accidentally changed settings that would have made data publicly exposed, that they either don't have the ability to make those changes, or if they make them, those changes will be overridden and data will never be exposed. So it's a very powerful tool for controlling access into S3 of data in S3 and making sure that it never goes public. Another thing is increasingly, if you think about like FINRA is a big data lake public reference for us, that's a lot of financial data that comes under regulatory restraint. Same thing for people in insurance, a number of use cases. You have to make sure that that data is retained in case the regulators come back and want to look at it. So we introduced S3 Object Lock, where now you can have data in your data lake, apply object lock policies so that data can't be accidentally or intentionally deleted, and then prove to auditors that that data has been locked down, it hasn't been touched, it hasn't been changed in a way that meets SEC and a wide array of industry requirements. So now you can have both your data lake platform, which also now is a compliant data storage platform, all in one through S3 Object Lock. And if you set up archive policies and move that data to a lower cost tier, it follows the data, not the storage tier that it's stored in at that moment. So it really is applied to your data, irrespective of what tier that data lives on. But then the second key element is metadata security, and that's where Glue Data Catalog comes in. Glue Data Catalog is the foundation for analytic tools to be able to know what data is in the data lake what relationships between different data sets are, and start to give you a view of what data you can process. But as I'd mentioned, you're probably going to want to materialize views that are specific to someone's role. So if you have a BI person who is just looking at running monthly reports on very specific data sets, you're not going to want them to see all of the data in the environment, which you may want someone like a machine learning specialist who is going to build, you know, um, very specific models and test those and develop those to see multiple types of data. And so essentially, we use Glue to materialize those different views and manage who can see what data and what are the relationships between those data so that they only can query the data that they're entitled to. So metadata security, data security go hand in hand, and IAM is the control point for both of these elements. And so essentially some key learnings we've had is you create and maintain this centralized data catalog in Glue, which is your master record. You enable cross-account access and use capabilities inherent in Glue to where different accounts can have different views of data, but then different accounts can share views of data, and then use IAM policies to control that catalog access and narrow it down to only the view that someone is entitled to for their specific role. And then finally, as I mentioned, encryption is the protection against inadvertent data exposure, because without the keys, you can't read what the data actually means. And so there are a number of fine-grained resource policies in Glue to restrict who can view what and what they can query. A few examples here are, based on who a user is, they can only see certain tables, certain partitions, and only, maybe query or write, a subset of those partitions. So it gives you a very fine-grained view of who can do what and maps it to their roles and their capabilities. Finally, to wrap all this up, this all sounds complex, doesn't it? And for a lot of people, it is. When you think about building a data lake, even though we've tried to automate a lot of this, provide a lot of tools, it's still not easy. You've got to set up your storage foundation layer in S3, apply security there, start to set up all those ingest policies using all these different tools that I mentioned, then set up your cleansing and data prep and cataloging processes, hopefully start to automate that, start to apply this role-based security so that security really matches a person's role. And if they switch roles, the view of what they can do is appropriate to that role, even if it's the same person in a different role. The security doesn't follow that person, it follows their role. And then, ultimately start to analyze that data. Those are all very typical steps, and it can take weeks to months to start to do this at large scale. So, in the spirit of democratizing data lakes, making it easier for people to get value out of their data more quickly, getting to time to results, we really wanted to focus on how to make this whole process of building and operating and implementing a data lake much simpler. So, for those of you that watched the keynote at reInvent last year, or maybe have read some of our press releases, we're introducing, and it's in preview now. So if you haven't used it, I'd encourage you to sign up and try it. And it will be going live in the near future. AWS Lake Formations, where essentially we're starting to automate a lot of these complex steps to build and operate a data lake so that you can essentially build a secure data lake in days rather than weeks or months. And so the way that works is you can go to a console view to do this. You essentially create your data lake, and that defines that storage foundation and starts to build that out. Define data ingest pipelines of how you want to import data into the data lake and register those data sources. You can start to set up the catalog to automatically catalog those. Control security so that you're controlling by user permissions and table permissions, so you can give very specific views to users depending on their groups and roles. And then ultimately start to allow people to collaborate and use that data by searching the data catalog, seeing what they can use that's appropriate to their role, enriching metadata so that they can add specific data to it, and ultimately spinning up the analytic tools that they're going to use, allowing them to run their jobs, and then allowing the security and governance folks to monitor activity, audit what users are doing, and download those logs. And do this in all in an automated fashion. Because ultimately, we want to make data lakes easy. We've seen these 10,000 plus customers realize value for doing it, and we want to allow you to do it easily as well and join that club. So what we want to do is boil this down so it's as simple as 1, 2, 3 to take raw data, get to business value from that data. So we start by building the data lake to centralize and collect that data, remove data silos by getting all that data into S3, bringing the tools to it, catalog and transform that data. So you take raw data sets, make them usable to get actionable insights. That's where Glue comes in to discover it, transform it, get it ready for use, and then ultimately bring whatever tools you want to use today, as well as any tools you may want to use in the future as you get more sophisticated. Bring those to the data as well so that you can extract value from it as quickly as possible. So at the end of the day, that's really what we're trying to do to help you build your data lake is make it simple, make it cost effective, make it quick and easy, get you time to results as quickly and easily as possible. So thanks for joining. Hopefully this was useful. Reach out if you have questions.